Okay, so if you're taking any sort of algebra course, things like Algebra 1, Algebra 2, College Algebra, you're definitely going to have to be able to do a problem like this. And what we're talking about here is a quadratic inequality. So if you think you can solve this, go ahead and pause the video. Now, unfortunately, you can't put the solution to this into the comment section because the solution to this is actually a graph. Now, it would be pretty cool if you actually post your graph in the comment section. Maybe one day you'll be able to do that. But here's what I'd like you to do. If you think you know how to do this, just tell me the basic steps, maybe like one, two, three, step one, step two, step three, as if you were going to tutor someone on how to solve this basic equation. Now, if you're kind of lost here, no problem. I'm actually going to explain this to you step by step, but this is definitely something you need to know if you're taking any one of those algebra courses I just listed. But before we get going, I'm going to go ahead and quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I absolutely love teaching mathematics. And I can tell you right now, you can be successful in mathematics, but what you need is great math instruction. Of course, you need the desire to learn math and you need some encouragement, but most importantly, you need instruction that you actually understand. So, if you need help in your current math course, or maybe you're studying for some sort of special test that has math on it, I'm talking about things like the GED, SAT, ACT, GRE, GMAT, ASVAB, Accuplacer. I can go on and on and on. Teacher certification exams. A lot of you out there are probably not even aware of it, but if you have any kind of ambitions to going to college or some sort of secondary vocational training, you're going to be having to take entrance exams, placement exams. So you're going to be taking one of these exams I'm talking about, and of course, they have very, very important kind of outcomes for you. So you want to do well on these exams. And if you're homeschooling mathematics, check out my Math Help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses that span these categories and much, much more. I'm also going to leave links to my math notes. Now, it's important that you have notes, okay, because you need to study from something, and you certainly just can't memorize all this. So, hopefully, you're taking your own awesome notes. Now, if you're not even taking notes, you need to start working on this. This is a skill, but it's very, very important for your ability to learn mathematics. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. So you can see here I have some graph paper in my background because, again, the solution to this is graphical. And let's go ahead and take a look at the answer right now, and then we'll talk about exactly how to do this. So here is the solution. And these points right here, this is actually -2 right there. This would be 2, and right here is -4. So what we have is a graph of a parabola. And as I indicated, the solution to this is what we call a solution region. It's everything on the inside here to include the actual graph. So this is the answer. How did you do? Well, if you actually got this, well, that's pretty impressive. Certainly impressive enough for a nice little happy face in A plus, a 100%. And let's throw in some stars so you can have an extra special day for your awesomeness in algebra. Okay, so nice job. So a lot of you out there are kind of maybe thinking to yourself, well, how do you even graph this? What does this even mean? Well, let's go ahead and talk about that right now. Okay, so what we're talking about again is something called quadratic inequalities. All right, this word quadratic is basically talking about second degree polynomials, things like right here, this x squared minus 4. So let's just go ahead and get rid of this inequality symbol here for a second and just write this, y equals x squared minus 4. Okay, so this is a quadratic equation. Now I could write this as a quadratic function, basically the same thing, but hopefully you know that we can graph this equation. So what's the graph, or what's the general shape of a quadratic function? Well, it is a parabola. So U-shaped type thing like this, or looks something like that. And you need to know how to graph parabolas in order to do quadratic inequality. So that's kind of the first kind of prerequisite. Now, if you are studying algebra, and you're not really comfortable with graphing quadratic inequalities, you still have confusions on any confusion, not confusions. I don't know, maybe that's a word. But anyways, if you are lost about any of this stuff, let me go ahead and just give you a couple quick recommendations. One, I have additional videos on my YouTube channel on all these topics, but really I would strongly suggest checking out one of my algebra courses, like an Algebra 1, Algebra 2, not pre-algebra, because you don't really get into quadratic functions in pre-algebra. So check out Algebra 1, Algebra 2, College Algebra, courses like that. I teach all of this stuff thoroughly. But anyways, you need to know how to graph a parabola, which of course is the graph of a quadratic function. You also need to know how to solve quadratic equations. Okay, that's really important as well. So for example, here, we're going to want to solve the equation x squared minus 4 is equal to 0. And that's pretty easy to solve, but if you're struggling with any of this stuff, these are two kind of sub skills that you're going to need to be able to do in order to solve a quadratic inequality. All right, but let's go and take a look at the steps here. So this is the general steps, and I asked you to put this into the comment section. So if you had something like this, then I think that's pretty acceptable. So the first step is we need to graph the parabola. Now you can see here that I have some dotted lines and I have a solid line here. So if our problem, you can see this is y is greater than or equal to x squared minus 4. So we need to kind of focus in on this symbol here. So if you're dealing with a greater than or equal to or less than or equal to, when you actually graph your parabola, it's going to be a solid graph, something like this. If this happened to be a problem like, let's say, greater than, or not greater than or equal to, just greater than or less than, when you go to graph your parabola, it's going to be a dotted line. I'll speak more about that later, just so you kind of know that when you do graph, you have to really be aware of what symbol, inequality symbol that we're dealing with. Okay, so that's the first thing. Now, how you graph, of course, these are some sub steps. There's some steps in here that we'll talk about, but basically what we need to do is get an accurate graph of the quadratic function on our graph paper. So the next thing we're going to do is we're going to test a point, okay, an XY point. And for the most part, the point we're going to be testing is 0, 0. There's one exception to when we're not going to be testing the point 0, 0. Of course, I'm going to explain to you what it means to test a point, so we'll just hold on for that for 1 second. But I'm just giving you an outline of the steps we need to do. And then after we test a point, like the point 0, 0, that's going to indicate to us where the true region is. Okay, there's a true and false region. And then we're going to go ahead and shade the true region. So these are the steps that we're going to follow. And let's go ahead and get into it right now. And of course, we're going to start on graphing this quadratic inequality. Okay, so right now we have y is greater than or equal to x squared minus 4. So for this part of the problem, don't even focus too much on the inequality symbol. Just think to yourself, how would I graph y equals x squared minus 4? Okay, so how would you graph this parabola here, y is equal to x squared minus 4? Again, hopefully you know how to graph parabolas. And there's a lot of different ways, you can graph parabola here. This is super easy. Of course, I'm not going to try to teach all of these sub-skills in here because this video would just go too long. But basically, right here, this is the y-intercept. This is negative 4 down here. 1, 2, 3, 4. There's negative 4, okay? And this x squared, right there, this coefficient in front of the x squared, in other words, this is a positive 1x squared minus 4 because there's a positive sign, not a negative sign in front of the x squared. That means this is going to be a happy parabola, okay, like a happy face parabola. If this was negative, like a negative x squared, it would be a sad parabola and it would look upside down. Okay, again, if you don't know how to graph parabolas, quadratic functions, you need to review that in order to do these quadratic inequality problems. Okay, so I could just say, oh, this is the y-intercept and just draw a nice little parabola like so. But we can kind of take it a step further, okay? What we can do here is get the x and y intercepts, all right? Now this -4 is the y-intercept. Let's just talk about the y-intercept real quick. The way you get the y-intercept for any function that you want to graph is just let x equal to 0, okay? And we're talking about the point where a graph intercepts the y-axis, okay? Like this point right here for whatever function. This is going on right here when x is 0, okay? So if we plug in 0 into our function, we'll get the y-intercepts. That's one way you can identify it. Of course, right here, if you understand how to graph parabolas, you can just see, oh, this is the y-intercept. In other words, our parabola is going to cross the y-axis at -4. So just go ahead and mark that point there. Okay, so now to make this graph even more accurate, we can get the x-intercepts, and the x-intercepts are effectively solving this quadratic equation. So you're going to take this function here and set it equal to 0. So we're going to go x squared minus 4 is equal to 0 and solve. So this is super easy to solve. So we're going to say x squared minus 4 is equal to 0. We're going to move that 4 to the other side. So we're left with x squared is equal to 4. How do we solve for x? Easy. We take the square root of both sides. So x is equal to positive and -2. Again, if you're lost on any of this stuff, you need to review what you have to review, okay? But just, it's okay to be like lost on something. Like, I don't get this. That's actually a good thing because then you have something very specific you can work on. All right, so these are what we call the zeros, or the x-intercepts, or the solution to the quadratic equation. And there's another word for them too, roots. There's a lot of words for these solutions, but what we're talking about is these are real number solutions. So this parabola is going to go through the x-axis at 2 and -2. Okay, these are real roots. So now when we go to draw our parabola, now we have to keep in mind that this is going to be a solid line. Again, if this was just greater than or equal or greater than or less than, okay, it would be dotted line, okay? And we'll talk about the reasons why that is important now. So we could just go ahead and sketch our lovely little parabola just like so. All right, so that is the first step. And if you understand that, that's pretty good. I mean, really, that's probably the hardest part of the problem. But let's go ahead and continue on. So here is our lovely parabola. So that's step one. So what we're trying to do is identify which region is true and which region is false. So basically we have a true region or a false region. We're looking at this parabola like the inside and outside, okay? Either the inside is true and the outside is false, or the outside is false and the inside is, no, it's supposed to say the outside is true and the inside is false, right? So it's one or the other. So you don't have to identify, all you have to do is identify one point to whether it's true or false, and then we can shade the true region. And I'm going to explain to you what that means here in just 1 second. But anyways, this is the result of our step one. So now, okay, we kind of go back to our notes. We did step one. And what we want to do now is focus in on step two, which of course is we're going to test a point. We're going to test the point 0, 0. Okay, so what does that mean? You can see I already did the work here, but where is the point 0, 0 located? So x, y, right, that's an ordered pair, a coordinate. So 0, 0 is located here at the origin. Okay, we're testing inside the parabola. I'm testing this region in here. And when we're testing a region inside or outside the parabola, we could just test any point that's inside the parabola. I could test this point. Here, let me use a different color. I could use this point, test that point, test this point. It doesn't make a difference. As long as it's on the inside of the parabola, that's perfectly fine. But listen, why make your life harder? The easiest point to test is 0, 0. If you can't test 0, 0, test the point 1, 1. Use simple numbers. No need to be a math hero and take on some, more challenging numbers. Just use a simple point. Now, when can't we use 0, 0? Well, the only time we cannot use 0, 0 is if our parabola actually goes through the origin. If it goes through the point 0, 0, then we have to pick a different point. So you can't pick a point that's actually on the parabola because we're trying to determine which side of the parabola is true or false. So what does it mean to be true or false? Well, I'm going to show you this right now. So again, we're testing this point 0, 0, which is located right there. And we're going to plug in these values. X is equal to 0 and y is equal to 0, which of course is the point 0, 0. We're going to plug all this in into this inequality, and let's see what it tells us when we do that. Okay, so again, we have the point 0, 0. We're going to test it into our inequality. So I'm going to plug in 0 for y and 0 for x. You can see I'm just going to replace these x and y's with 0. So 0 squared is 0. All right, I'm looking at right here. And 0 squared, this is not squared, this is just 0. Look, see, even when I do this stuff, I can catch a little tiny error. And that is I'm glad I made that little mistake, because when you're doing math, if you make a little error, as long as you catch it before you turn in your work, right, to your teacher, that's perfectly fine. That's why you always want to be double checking, triple checking, because it's easy to make a mistake. As long as you correct it before you turn in your stuff, that's perfectly fine. Okay, so we have 0 for y, and then 0 squared for x squared minus 4. Okay, so now let's go ahead and just simplify this. This is just going to be 0 is greater than 0 squared, of course, is 0. So we end up with this statement: 0 is greater than negative 4. So we have to ask ourselves, is this true or false? Okay, is 0 greater than negative 4? Now, hopefully, none of you said, no, that's false. No, that is true, right? Let's just make sure we understand. Here's 0 on the number line. Here's negative 4. Okay, numbers to the right of numbers over here are greater than. So yes, indeed, 0 is greater than negative 4. That is true, okay? Meaning that this point in here is true. So this is our true region, i.e. any point that we select in here will satisfy this inequality. Okay. All right. So let's go ahead and just kind of put a little point there. That is true. And what do we do next? Well, let me kind of go back over here. Let's go back up to our notes. So we tested a point 0, 0. In fact, it is true. So we're going to go ahead and shade the true region. Let's go ahead and do that right now. All right. So pick a nice color. When you're doing math, doing stuff like this, you want to always use pencil. You can kind of use kind of different variations of your pencil shading, but color pencils come in handy as well. So you're just going to put some nice shading in here like so. Whatever you do, don't scribble on your paper like that. Just be nice and neat so your teacher knows what you're talking about. So let's go ahead and talk about this point where sometimes your graph, okay, if it's greater than or equal to or less than or equal to, you're going to have a solid line as your graph. If it's greater than or less than, it will be a dotted line. Now, what's the point there? Well, this is a very important kind of little detail. What we're talking about is the following. Points that are actually on the parabola, okay, will actually be part of the solution region, okay? So any point that's actually on the parabola will make this true as well, okay? So that's why, a solid line, that's what it's indicating. If we had a dotted line, okay, so for example, if our parabola was like so, and we had a point that was on the parabola, that would not be a part of the solution region. But let's go ahead and just kind of test our theory here, or not our theory, but let's just kind of reinforce something. So I'm saying all the points in here, if we test any point into our little quadratic inequality, it will end up with a true statement. So what we're saying here is if I test a point outside of this, we should end up with a false statement. So let's go ahead and test a point outside of here, and I picked a lovely point. Let's pick the point 5, negative 1. So that would be what? 1, 2, 3, 4, 5, negative 1. That point right there, this should be false because it's outside of the true region, right? So let's just go ahead and verify that just to kind of quench our curiosity. So here is our quadratic inequality. Let's go and plug in 5 and negative 1 into our inequality. So of course 5 will be, we'll plug that in for x, and then negative 1 will plug in for y. And you can see the work right here. We're going to end up with negative 1 is greater than 21. You can see all the work right here. what I've done. So is -1 greater than 21? No, right? That is false. So that kind of just verifies that. So you could, like, for example, pick a point way over here and then just test that point. Oh, that point's false, therefore inside is true. But always use 0, 0 as it is the easiest point to use. Okay, so this is how you do quadratic inequalities, and this was a very simple kind of parabola or quadratic function to work with. You certainly can have much more complex inequalities, and inequalities in terms of functions, they are everywhere in mathematics, so you need to know how to do them. Again, if I'm saying this is an algebra must know, I really mean what I'm saying. Okay, so if you struggle with any part of this problem, don't panic. Okay, what you need is a nice little to-do list. Okay, the worst thing you could do is just say, oh, I don't need to, or maybe just cross your fingers and say, I hope I don't see these problems again. No, you will see these problems. They're very important in mathematics that you know how to do. So just work on what you don't know and improve. So again, if you need help with quadratic functions, inequalities, etc., probably just check out my Algebra 1 program or Algebra 2 program, and you'll be good to go. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.